Section 11.7 for geometry. Now we're going to still do volume, but this time of pyramids and cones. Reminder, the difference between a cylinder, or cylinders and prisms. Here's a prism. Here would be a pyramid with the same base. Here's your pyramid. Put that on top. It's got the same base. Definitely doesn't take up the same amount of volume because it's pointed at the top. Same with cylinders and cones. Here's your cylinder. Here's your cone. Same base. Definitely does not take up the same amount of space when talking volume. How much space does it take up? A pyramid takes up exactly 1/3 the amount of its original prism. So if this was your prism, capital B times H, this pyramid, believe it or not, takes up 1/3 that amount of space. And if you're in class, we'll do an activity to prove that. How about a cone? Same, 1/3 pi r squared H. Let's take a look. Practice some. Find the volume of a regular pyramid with a height of 7 centimeters and has a triangular base with sides of 8. Triangular base with sides of 8, we can assume then that it's a regular equilateral triangle if they don't tell us anything different. We don't have to draw, you don't have to draw the entire pyramid. Our volume is 1/3 capital B times H. 1/3 capital B is 1/2 base times height, and we need height of the prism. We know the 1/3. We know the base has sides of 8. We're going to find the height, and the height of 7 centimeters is the actual height of the pyramid. So all you really need to draw is the equilateral triangle. Work with its base. You know that the sides are 8, 8, and 8. So if we cut it in half, it would be 4. 1/2 the base is 4. What is the height? We've been working on this, 30, 60, 90. The height is 4 square root of 3. This height, again, is the height of the pyramid. And let's remember that the height of the pyramid, if they tell you height, it goes from here to here, straight up through. How high is it from here to here? Add a perpendicular straight up, not the slant height, but the straight up height. So if they tell you the height is 7, it's 7. Let's do that. We'll have an exact answer and an approximate answer. The volume equals 1/3 times 4 times 4 times 7. Which is going to be, we need a 1/3 times that, but you cannot put a decimal in there if we're working with that. It'll be 1/12 over 3 square root of 3. 4 times 7 is 1/12. 1/12 over 3 square root of 3. What is that approximately? 37.3 cubic centimeters. No, it's not. No, it's not. I got to get my square root of 3 in there. My bad. 1/3 times 4 times 4 times square root of 3 times 7. Thought that was too small. 64.7 cubic centimeters. Let's try the hexagonal pyramid. Hexagonal pyramid has a side of 10 and a height of 14. The pyramid has a height of 14. Again, we do not have to draw the entire height. We do not have to draw the entire pyramid and label the height. Capital B times H, it is a pyramid, so we need 1/3 of that. So this is going to go as 1/3. Capital B of a polygon is half base times height times number of sides. And we're going to multiply that times the height of the pyramid itself. All I need to draw is the triangle for the hexagon. Do not need to draw the entire hexagon. You could put pieces of it if you wanted to, knowing that these are all 10. And in a hexagon is made up of more 30, 60, 90 triangles. Half the base is 5. Height is 5 square root of 3. So we're going to go with 1/3 times half the base, 5, times the height, 5 square root of 3, times number of sides, 6 in a pyramid, times the height over all of the pyramid, which is 14. Now, when you multiply this together, if we want the exact answer, the square root of 3 is the only thing that's irrational. Let's take 1/3 times 5 times 5 times 6 times 14. And you get 700 square roots of 3. What is that approximately? That would be 1212.4 cubic centimeters. And you're thinking, that's a pretty big number. Well, yeah, it's a pretty big pyramid. The height is 14 centimeters. Each side is 10. It's going to take up a lot of space. Okay, so now we're going to do a cone. And you could probably draw a cone, but when you draw a cone, don't make the base a perfect circle. You want it to go a little bit three-dimensional. So draw an oval, pick a point at the top to be the vertex. Just make a little clown hat there. There's your cone. With a diameter of 5 feet, please take note that that's the whole entire diameter. We don't need a diameter. We work with radius. So the radius is 2.5. The height of the cone is 7 feet. The height is 7 feet. That means if they said height and not slant height, they went straight up the middle. Or you could label it out here. From here to here is 7 feet. Doesn't matter either way, it's 7 feet. Volume of a cone is 1/3 pi r squared h. H being the height of the cone. So we want 1/3 times pi times 2.5 squared times 7. I'm going to turn these into x's because I have a decimal point there. Let's not make a mess out of that and try to turn it all into a fraction. Let's just go with the approximate answer. To the nearest tenth is 45.8 cubic feet. 1/3 times pi times 2.5 squared times 7. Let's try this one. Find the volume of a right cone with a radius of 4 and a slant height of 9. Okay, they're all right cones. I don't know why this one said specifically that it was a right cone, but we're only working with right cones. So again, you probably want to draw the cone to have a visual, plus the cones are easy to draw if you can sort of draw an oval. But this time it says its radius is 4, but its slant height is 9. Slant height isn't going to help us. We need its actual height. How do you find the actual height? We're going to need the Pythagorean theorem. So, a squared plus b squared equals c squared. Take 9 squared minus 4 squared. Make sure you're minusing on this one. And you get 65. Of course, the height isn't 65. The height is the square root of 65. Then we'll go ahead with the volume of the cone formula, which is 1/3 pi r squared times h. 1/3 times pi times 4 squared times the square root of 65. And again, let's not make a messy radical fraction out of this. We'll just go with the approximate answer. 1/3 times pi times 4 squared times the square root of 65 equals approximately 135, that's a 5, looks like an 8, 135.1. And we are in cubic inches. And there you go, with volumes of pyramids and cones. Good luck.